Awesome. Now we're joined with Mark Hoffman. So thank you for being on today.
Absolutely.
And he's head of design and engineering for the zoo, and really excited because now we're going to be moving from the front of the house here, kind of behind these gates. We're going to check out what it takes behind the scenes to make this exhibit work. All right, so kind of got behind the scenes a little bit here, and first thing we're seeing, giant storage tank, got some chillers in the background. So Mark, why don't you give us a little background on what's going on right here?
Absolutely. This large silo right here is our brine mixing tank. So we actually have food grade table salt delivered to mix water, make brine for our sea lions.
Very cool.
Carly showed you 3 large and 3 small exhibits. The 2 of the large exhibits are saltwater. That's the aquarium and the sea lion tank. The penguin tank is actually freshwater.
Interesting.
And because the sea lions don't breathe the water in and out like the fish do, the kind of salt that's in the water is not as precise as a requirement. So we actually use food grade table salt to make that into salt water.
Interesting.
A very similar.
Would not have thought about that.
Yeah. So periodically we have a large truck arrive and blow salt into this tank. We mix it with water, make brine, use the brine to control the salinity of the exhibit. Behind the tank is a 750 kilowatt generator. It's one of the larger generators here at the zoo, tied for first place.
Wow.
That generator actually backs up all of the life support systems we have in the back of house here. When we say life support systems, what we're referring to are the filtration, disinfection, and temperature control systems that keep our animals healthy.
Yep. So this is really interesting. We've kind of come down like a mini loading dock here before we get into the plant. And they've got, the big floodgate here, and you're seeing these a lot in this area in the Med Center. Obviously back in 2001 with Allison had a lot of flooding issues in this area. So these flood gates, they can probably drop in additional panels to fill it out, right? And then you got this barrier that's going to prevent flooding into the plant, prevent a lot of damage and headaches.
I think Carly told you about how beautiful the front of the exhibit is and how much goes on in the back to keep it running. So when we built this, we actually intentionally dug down to pour the slab for this plant so that you couldn't see it from the front. Because a lot of the system actually works through gravity flow, hydraulically. And so the highest point of the filtration system is actually screened by the rockwork and the green roofs in the front. So every foot higher we build in the back is another foot we have to address in the front.
Gotcha.
Which is a big reason why we dug down here. But you're exactly right. We're in the 500-year floodplain here in the Houston Zoo, and so flood protection was critical for us.
Yeah, makes sense. All right, so now we're in the plant, and obviously we've got the most important piece of equipment in here, the Cougar Spartan control panel there, small sump pump panel. It's doing like probably 0.5% of what's going on in this entire plant. So
yeah, I'm glad you mentioned that. Actually, it is one of my favorite facts about this exhibit is that there are almost 3 miles of process piping alone underground in this exhibit.
That's incredible.
That doesn't account for above ground piping. That doesn't account for plumbing or civil utilities. That's only the life support system piping underground here. Our builder likened this project to a industrial facility like you might see out in East Houston.
Right.
Underground instead of above ground.
In the middle of a zoo.
In the middle of the zoo, exactly.
Yeah, in a public area.
Yeah, so logistically, getting this built, you can see lots of really tight geometry. It was really a complex construction project.
But it's clean. I mean, it doesn't seem like, there's a lot of stuff in here, but it doesn't seem like overwhelming or like closed in or dark. Or
absolutely,
like
and labeling and legibility of the pipe runs is critical for us.
Yeah.
Our life support operators actually are in the plant several times per day, really all day, turning valves, backwashing filters, ensuring that pool levels are balanced with holding pools in the back, mixing salt to make brine, adding brine to increase salinity, and so on and so forth.
It's hard to recreate Mother Nature.
That's exactly right. It takes a lot of engineering to recreate Mother Nature. Yeah, that's absolutely right.
Wow.
So we're standing in front of actually the penguin filtration system. So like I mentioned, the penguin system is freshwater. We have some pumps over here that pull water from the exhibit, run the water through sand filters. And then we actually have an ozone contact chamber here. So we use ozone in each of the exhibits in this plant for disinfection. It's like chlorine, it consumes organics in the water through oxidation, but unlike chlorine, it has fewer residual byproducts from disinfection. So the ozone is off-gassed here, taken into the ozone destruct, so the plant operates safely. and then that water is run through this deaeration tower here to remove the bubbles and micro bubbles from the water, and then brought back into the exhibit.
So this tank is actually full.
Yes, this is full of water.
It's like you said, free of air.
You got to check all the bolts.
Sure. It doesn't look like anything from there.
Yeah.
So what's been really interesting is a lot of the equipment that Mark's talked about is for setting up the environments, for the animals, cleaning the water, but a lot of the equipment that we're seeing is very similar to things that we see in a commercial building, just used in a totally different way. So we've got large RO system here, so Mark, I'll let you kind of take it away from there.
We have a centralized RO system here, reverse osmosis, creates very, very pure water. We actually have storage reservoirs here as well. We run this through a polishing filter, and we actually send this water on a loop through the entire exhibit facility. So we actually have in the building an RO water loop, like you would have domestic tap water, but it's absolutely pure. We use that in the smaller exhibits primarily inside the building.
Yeah, it's cool. I mean, it's a similar idea to like a hospital where you'd have you generating the RO, you're storing it, and then pressurizing a loop back, and then it might get kind of re-scrubbed as it's going back through. So yeah, it's very, very similar kind of application in a totally different way. Yeah. And again, it's all plastic piping, plastic fittings that pure water would just destroy normal piping.
Absolutely.
So yeah, it's really cool. So kind of moved on to a different spot in the plant. See some big pumps behind you, but they don't look like the pumps that we normally deal with. So
we're right in the heartbeat of the facility here. These large pumps are actually the pumps that pull water from the main aquarium and run it through the filtration process to polish the water. We use sand filters for the main aquarium. We have similar pumps just over here for sea lions.
Okay.
But both systems actually start by being pumped all the way up to the roof. There's 2 floors above us. On the 3rd floor in a penthouse, there's actually a filter called a drum filter.
Okay.
And that screens out the first sort of flush of large particulates that are suspended in the water. Obviously, the main aquarium, being indoors, has a lot less of a solid particulate load than the sea lions, also because of the animals themselves. So the first sort of largest particle size is screened out on the drum filters above, and then we use gravity flow to deposit the water into this massive holding tank you see here built out of concrete.
Oh wow, that's a tank.
That's a tank, yeah,
okay.
Absolutely. So half of that is for sea lions and half of that is for the main aquarium. You can tell which side is which because when it's warm outside, one of them sweats like a drink. Yeah, because it's 65-degree water in there.
Gotcha.
There's a main distribution box in the top of that vessel, and we control most of our other processes off that box distribution throughout the entire plant. And if we go around the corner, I can point out some of those systems.
Sure. I do want to talk about this pump a little bit more.
Yeah.
To me, this is fascinating. So this is the pump end itself right here. And so the suction's coming in here, going around the volute and then up and out. But what makes this different is it's like a composite material. It's not metal. Like typically this would be out of a cast iron and it's really heavy. So to kind of see this, feels like fiberglass, kind of a composite volute is really cool. And I'm guessing that just has to do with everything that's going on in the water and not wanting to affect the chemistry and things like that. So to kind of see, totally non-metal pump end is really cool.
Yeah, the salt in the water, as well as in sea lions, we actually have a chlorination process that we can use if we need to add a little bit of disinfection on top of the ozone. And chlorinated water can actually react with cast iron as well.
Yep. Great. All right, cool. So now we're kind of into a lot more of the filtration equipment. So kind of talk us through what's going on in these different spots.
Yeah, we're standing in front of a Defender filter. This is a perlite filter, commonly used in large-scale swimming pools, actually.
Okay.
We selected this technology, among other technologies, as a way of saving water and saving energy.
Okay, does not require a blowdown?
It doesn't require as much of a backwash as a sand filter would, yeah. Okay. So what you can see here, actually, if you get close, are some tubes we call noodles. And those noodles are actually coated in perlite, which is kind of like diatomaceous earth.
Okay.
So when we use this large pump here to pull water out of the distribution box that we talked about a moment ago that's made of concrete above.
Yep.
We pull water from the distribution box and push it through this filter where the perlite actually removes very, very fine particulates in the water, down to several microns. Okay. And then unlike a sand filter, what we're able to do is what's called a bump. And we use air pressure to actually shake these tubes and release the perlite from the tubes or the noodles. And then when they recoat, you get another use out of the perlite. So we're able to use the perlite several times over, and then once it's exhausted, we actually drain it into this floor sink right here below us.
Okay.
Refill the filter, recoat the noodles, and move about our day. But it uses a far less quantity of water each year than sand filters.
Than a traditional backwash. Okay.
Yeah. And I've sort of implied it, I suppose, but of course we also recirculate our pools. Carly, I think, talked to you a little bit about how zoos have progressed in terms of the conceptual designs and the interpretive messaging that we have in our exhibits. Right. We've also moved forward, of course, a great deal technologically. Zoo exhibits several decades ago would often fill pools with potable water, and then once the water was dirty, drain it down to the sewer.
Oh wow!
And that process in the the 19th and 20th century is, of course, extremely water intensive.
Yeah.
So now we're able to preserve the salt in the system. Being a closed loop system, your salinity doesn't really change, or your salt mass doesn't change.
Right. You have to make up to be able to maintain. Sure.
And we actually are able to use the water many, many times over before we have to replenish it or add some.
It's very cool.
Yeah. So here we have our 4 fractionators, protein skimmers. And like I said down below, we actually pull water from the main aquarium system and the sea lion system.
Right.
Bring it up here, inject ozone in the contact vessel below, create this really nice foamy head that's pushed up in a clear cone and then skimmed off the top. So the water in the vessel is being contacted by ozone. That updraft of gas is pulling that foam up to the surface. It overflows.
And it takes like so what is it trying to get rid of when what's coming up with it?
Primarily proteins, but organic products in the water. Fecal matter, leftover food.
Gotcha.
Plant material that blows in. And as it's oxidized and broken down, it's suspended in that foamy substance. And then that foam comes up, and you can see kind of some of the residue on the sight glass there. It actually just goes up and then is rinsed down into the drain. So it's very water efficient. And it's actually, like I was saying earlier, one of the more artful parts of the exhibit is our operators have to balance that valve really precisely to get enough foam but not too much.
Okay.
If you overdo it, then you start to lose water in the tank.
Right. I mean, I can see you got about 400 gallons a minute going through there, so it's quite a bit of flow.
Yeah. Yeah, and that's actually the flow in and out of the vessel back into the exhibit as well.
All right, so we've seen a lot of stuff in this plant that is definitely not typical for what we would normally deal with, but what we've got behind us is an application that we deal with all the time. So Mark, why don't you tell us about this one?
Yeah, absolutely. This is a sea lion heat exchanger. So to keep that water nice, crisp, 60 degrees for our animals, we actually pull a chilled water loop from the chillers in the back that we saw earlier. Bring the chilled water on one side of the heat exchanger, and on the other side of the heat exchanger, we actually bring system water, is what we call it. So we have water coming in for the sea lions behind this pipe here, and then going out right here. The plant has automation and has remote monitoring that we use with the SCADA system, but we also, it's always key to have analog, fail-safe detectors and meters on our exhibit. So we have a thermometer down there and a thermometer on the influent pipe. So we can always come and see, what's the temperature of the water coming in off the pool, what's the temperature of water going back to the pool. On a mild day like today, we're actually only chilling about 1 degree, so that water's holding temperature really well. But in the middle of the summer, that pool being outdoors, a lot of solar load, a lot of heat load on that pool. Got to keep it clean, keep it cool.
Yeah. It's really cool. I mean, it's definitely a cool application of this type of technology or system. Where we normally see it is primary, secondary cooling for a lot of equipment. So like an MRI would use a lot of cooling like this, and it actually goes to a third heat exchanger that's built into the actual MRI itself, but you got to cool that MRI unit to be able to run it. So these systems are really cool because it's a combination. You got pumps over there that are pumping on both sides. You've got control valves modulating that flow based on the temperature and the controls to make it all work. So really cool to see, kind of an application that we would normally deal with applied here for chilling a massive pool. What did you say? It's a couple 100,000 gallons?
250,000 gallons, yeah.
So it's a lot of cooling.
Yeah, our systems here go all the way from 250,000 gallons at sea lions all the way down to 25 gallons at the crabs.
Oh wow! So, that'd be a little easier to maintain than 25.
Yeah, for sure, for sure.
Cool.
So I told you earlier that we used table salt to keep the water salty for our sea lions. the fish have a much more demanding need for a specific, precise kind of salt.
Okay.
So what we see here is actually a crane rail that we use to hoist super sacks, so a cubic yard at a time, of what we call instant ocean. And that's actually, it's a precise mix of salts that mimic the salinity that's found in the actual ocean.
Right.
So we bring that super sack up, hoist it into the to the plant, and then below that crane rail there's actually an open plate that we drop the salt at a metered rate. We open the drawstring to a really careful degree, and we drop the salt out onto a concrete pan, and we have a manifold of pipes that inject the water onto the salt and make brine for our aquarium.
Oh wow,
yeah,
that's wild. And what do you have an idea, like what's that? It's like a 3% or so. Like what's that salinity of the water?
The salinity for both sea lions and the main aquarium, we try to keep it right around 32 ppt, which is about 3%.
Okay. Yeah.
PPT, parts per thousand.
And it's crazy because you go in the ocean and like if you taste it, you're like, wow, that's really salty. And it's like, it's only 3%
exactly,
salt that's making that happen.
Yeah, that's part of why we use brine to control salinity, because just a little bit of brine added translates to a lot of change in salinity.
Sure.
Yeah. So we're here in our water quality lab, and this is where our life support system operators actually test the water chemistry, checking salinity, pH, things like coliforms. Some of the information has to get reported to USDA, some has to be reported to AZA. We have very stringent welfare and health requirements for our animals, and keeping the water clean, of course, is the first step in keeping your animals healthy.
Makes sense. Yeah, this looks a lot more complicated than what you would do at a neighborhood pool or your backyard pool. Where you're just dipping in and looking at the little color spectrum, see if you're in the right spot.
Yeah, we do occasionally check ourselves with dipsticks here and there, but you're right. The upper end of the testing does pretty much exceed the residential pool industry.
Right. This looks more of like I mean, you said it's a lab. I mean, it looks like a lab you'd see in a school or university, something like that, more so than what you'd expect to see at the zoo. But it makes sense. You got to keep the water quality up.
Yeah, absolutely. We have a hood here. We use to mix chemicals and do titrations and dilutions. We actually have an incubator. We can use that to do coliform analysis. We have a titration setup here. So lots of sophisticated equipment in this space.
Yeah, very cool. I think you'd get yourself in trouble real quick if you didn't know what you were doing.
Exactly.
Exactly. Acid over there. I'm not.
Yeah, you're exactly
touch
right.
that. Yeah. So we are truly behind the scenes now of the big aquarium that we were looking at earlier with the sharks and the pufferfish and all of that. So really cool to see kind of what's going on up here. But can you kind of talk us through this?
Yeah, absolutely. So we're on the mezzanine of the main aquarium. We can see down into the coral reef below. You can see that back wall painted blue that Kali was telling you about. And you can also kind of see, if you look closely, that we actually dip down below the coral reef to give the illusion when you're standing in the front that you're actually looking into the open ocean.
Right.
But it's not the open ocean. You're seeing it here in the back of the house.
Yeah.
So a few features I'd like to point out. We have 2 medical pools on either side of the exhibit. We use that to separate animals that either need a little bit of alone time or in some cases actually need medical care. We also have this FRP catwalk system above the pool. And we use that catwalk system to actually hang these lights that were actually designed and installed by a theatrical designer and a theatrical installer.
Okay.
So these lights are all very precisely tuned to a specific wavelength based on how deep they're aimed in the pool.
Oh wow.
So we actually bring light into the water at specific locations to highlight the corals below. And the deeper that water is, the more red we have to put in that light to keep it looking natural down there.
Yeah, that's what it would be down there. Yeah, and it's crazy. You kind of see their different colors, tuned to different colors all over.
Yeah, you can also tell it's a lot balmier in here. It's a lot warmer.
It's a little warmer in here.
It's a little warm, yeah. The water here is warm, and so we keep the air warm. That reduces the evaporation out of the pool, conserves more water.
Right.
And you can also hear the whirring of the fans. So if we weren't to disturb the surface of the water at all, if it was glassy flat, you would actually be able to see through it from the viewing area on the public side, and see the catwalk above. So we actually blow a low air current across the water to keep those waves moving and keep that water reflected from down below.
That's interesting. Never would have thought about that.
Yeah, and as a civil engineer, I love this view also. You can see the CMU wall, you can see the cast-in-place concrete, and you can see the precast above us. We have almost every structural system you can imagine in this building. And we went with precast double T's in this space because of the saltwater environment. The quality control of rebar coverage and concrete consolidation in the shop is so good that it reduces our maintenance concerns in the long run.
That makes sense. Did you have to do any
concrete.
special coatings or anything on the concrete?
Not in the above ground space. All of the concrete is, we have an admixture called Zypex in the water, in the concrete rather. That admixture reacts with water to make a crystalline structure, so it's sort of a self-sealing concrete.
Oh, okay.
And
Very
then
cool.
the belt to the suspenders is that we actually go over the surface of the concrete with a product called Aquafin, which is a roll-on concrete waterproofing product. And for each of our aquatic exhibits, we actually we cast the concrete, we add the waterproofing, and we do what we call a water test. So we fill the tank up, and we mark the water surface elevation, and we check it 24 or 48 hours.
Make sure that
after it's filled, make sure the water's not going anywhere. Yeah, the last thing you want in any aquarium is a leak.
Yeah, especially with a tank this size. That'd be a problem.
Absolutely. And all the structural rebar in this tank and the sea lion exhibit are both galvanized.
Interesting.
Rebar.
It's very cool. This is awesome. I mean, you know, you never really think about what else is going on when you're standing down there looking at the glass. You get kind of lost in the exhibit. So it's very different to see it from this perspective and kind of see everything else that's going on, but also be able to kind of see the activity down inside the aquarium.
Yeah, absolutely.
It's really cool to kind of walk through all these different parts of the plant and see the different parts of the exhibit. But I mean, how do you kind of end up at the zoo doing all this? I mean, it's not, you know, our industry is not necessarily well advertised in general, but this is very specialized. So
it is very specialized.
How do you get into something like this?
Yeah, for me, it was really just a great deal of good fortune. I am a civil engineer. I went to school across the street here at Rice, graduated in 2011, and started working at Walter P. Moore here in Houston. And early on in my career, I got to work on a project with the Houston Zoo. It was actually the gorillas of the African forest down there in the south end.
Very cool project.
And I was just instantly bitten by the bug. I fell in love with zoo design. I didn't know how far zoos had come since I was a kid.
Sure.
And the Houston Zoo is just really a top tier, top flight zoo all around. Excellent exhibits, excellent programs. So the zoo became a client for me when I was a practicing engineer for about 6 years. And then when the Centennial campaign was announced, the zoo, which had previously used consultant program managers for construction projects, had decided to bring that practice in-house. So I jumped at the chance to apply for the job and was lucky to get it. Been here 7 years, never looked back.
Cool.
Yeah.
Very cool. Well, Mark, I really appreciate you walking us through
Absolutely.
The quote-unquote back of the house. I mean, it's really cool to see the exhibit, you know, as, you know, from the front like you would normally see, and it's very well done. It's very beautiful. This side of the, you know, house for me is really cool as well, because it's amazing what it takes to, like we said, recreate Mother Nature and kind of keep not only the animals alive, but, you know, give a good experience for everybody that is viewing. So thanks for kind of letting us behind the curtain here and check it all out.
Absolutely, and thank you for your part in making this happen.
Absolutely. So I have to sign off though. We have one more cougar panel over here, another little lift station panel. So it's very cool to kind of see again our little tiny part in this whole operation. So like I said, really enjoyed this opportunity to check out the front of the house and the back of the house of the zoo, and look forward to being able to do it again. All right, that was awesome. We just got the opportunity to walk through the Galapagos exhibit and see the behind the scenes as well as the exhibit itself. And you know, for me, it was truly an opportunity to geek out and see these systems applied in a totally different way. So really enjoyed today's showcase and look forward to seeing you on the next one.